Back. We are going to go over practice exam 2, problem 1. fx is 2x plus 6 by 2x plus 4. Find the derivative of f at x and find the derivative of f at 3. Okay, so this calls for quotient rule. Remember the quotient rule. F divided by g prime is denominator squared, derivative of the numerator, denominator as it is, minus numerator as it is, derivative of the denominator. So our function fx is 2x plus 6 by 2x plus 4. So the derivative requires squaring the denominator first. Derivative of the numerator is 2, denominator as it is, minus numerator as it is, derivative of the denominator. Simplifying, you get 4x plus 8 minus 4x minus 12, the whole over 2x plus 4 squared. Simplifying further gets you negative 4 by 2x plus 4 squared. That is overall a negative 4 by 2x plus 4 squared. Now derivative at 3, all I need to do is substitute x equals 3 in my expression for derivative. So that is negative 4 by 10 squared. That is negative 4 by 100, that is negative 1 by 25. So let me write my answers. The first one, negative 4 divided by 2x plus 4 power 2. Denominator is negative 1 divided by 25. Check. The answers are both correct. Okay. Next, let fx equals 5x plus 4 by x squared. Then the equation of the tangent line to the graph of fx at the point 2, 11 is given by y equals mx plus b. So this is the slope-intercept form. M is the slope, b is y-intercept. Okay, so apparently my answers are 4 and 3. Let's check. So my function, before I continue, first thing, how do we write an equation of a line passing through a given point with a certain slope m? It's given by point slope form. Sorry, your given point, your given slope. So y minus y coordinate of the point equals slope times x minus x coordinate of the point. We are given point 211. We need to find the slope of the tangent line. So that's what you need, slope of the tangent line. Slope of the tangent line at a point 211 is f prime at 2. What is f prime? What is f? F is the function whose graph you're looking at, you see. So f prime at the x coordinate. So that's what you're looking at. So fx is 5x plus 4 by x squared. Rewriting it, 4 over x squared is 4 times x to the power negative 2. When I take derivative of 5x is 5, derivative of 4x to the power negative 2. Negative 2 jumps down, 4x to the power negative 3. So that essentially gives me 5 minus 8 divided by x cubed. So that gives me f prime of x is 5 minus 8 over substituting 2. Why did I substitute 2? Because that's the point given to us. Point is 211. So 2 is the x coordinate. Okay. 8 by 8, 1, answer is 4. So that was just the slope, mind you. So if that's the slope and that's the point, what is equation of the line? So this is by point slope form. Y minus y coordinate is slope times x minus x coordinate. So y minus 11 is 4x minus 8. Add 11 to both sides. Y equals 4x plus 3. You understand? So 4 is the slope, y-intercept is 3. Check. Okay, next. You are given f at 5 is -4, g at 5 is 3, f prime at 5 is 7, g prime at 5 is 6. Find the following. Now this is multiplication, fg prime at 5, so product of two functions. Here is quotient of two functions, derivative. Another quotient, derivative evaluated at a number. So we know these formulas, right? So product, derivative. Derivative of the product, derivative of the first, second as it is, plus first as it is, derivative of the second. Now all we are doing is substituting argument 5. So f prime 5, g5 plus f5, g prime 5. So all I'm doing is f prime 5, that's a 7, g5, that's a 3, f at 5, that's a -4, g prime 5, that's a 6. So simplifying, I get -3. Okay, let's hope there are no mistakes. Quotient rule, f divided by g prime, square of the denominator, numerator is derivative of the numerator, denominator as it is, minus numerator as it is, derivative of the denominator. Now I'm evaluating this derivative at x equals 5. So I'm going to be, my argument is 5. Okay. So f prime 5. So I'm simply substituting f prime 5, g at 5 minus f at 5, g prime at 5 over g at 5 squared. Simplifying, I apparently get 5. Next. Likewise, the quotient rule g by f. Now here f is the denominator. So square, derivative of the top, denominator as it is, minus numerator as it is, derivative of the denominator. Substitute 5 as your argument. Using the values, I get -45 divided by 16. All right. Next problem. So, suppose y is square root x by x plus 5. Find the equation of the tangent line at this point. Find the equation of the normal line at this point. So notice y equals square root x by x plus 5. That represents a curve. So you want to use the derivative here to find the slope of the tangent and then proceed. Okay, so let's go through this. To find an equation of any line, for any line you need a point and you need a slope. Once you have point and slope, you use point slope form to write equation of the line. Y minus y coordinate equals slope times x minus x coordinate of the point. All right. So now for the tangent line at a point on a curve, the slope is given by dy dx, evaluated at the point. Normal line, what is a normal line? At a point is the line perpendicular to the tangent line. So normal line is the line perpendicular to the tangent line at that given point. Okay, so let's worry about normal line later. First, the tangent line. So as I said, to find this, for the slope of the tangent line is given by dy dx. Okay, so derivative of using quotient rule, denominator squared, derivative of the top, denominator as it is, minus numerator as it is, derivative of the denominator. Notice derivative of the denominator is simply 1. So simplify. So you have x plus 5 by 2 square root x minus square root x by 1 denominator squared. Common denominator. Okay, we need to multiply the second fraction by 2 square root x, numerator denominator. Combine x plus 5 minus 2 times, that gives me an x. And this becomes part of my denominator. Simplifying further, I get negative x plus 5 for the numerator and all of this for the denominator. That is simply dy dx. Okay, that's an expression for dy dx. You have a point given to you. You want slope of the tangent. So what do? You take dy dx, evaluate at this point. Okay, notice dy dx is an expression in x in our case. So all I need is x equals 4. If I had had a y here, then I would need the 2 by 9 in my expression. But fortunately or unfortunately, however, dy dx is only in terms of x, so I'm substituting x equals 4. And when I substitute, I simplify, I get 1 divided by 324. So an equation of the tangent line is y minus y coordinate equals slope times x minus x coordinate. So that's equation of the tangent line. Y minus y coordinate equals slope times, don't forget parentheses, x minus x coordinate of the point. Normal line is perpendicular. So slope of a perpendicular line is opposite reciprocal. This is positive, so now this is negative. Reciprocal of this is 324. So that's my slope. So y minus y coordinate equals slope times x minus x coordinate. Y minus y coordinate is the slope of the normal line times x minus x coordinate. Okay, so this completes problems 1 through 4. Next videos will cover rest of the problems. Until then, bye.